So our next step is to learn about computational thought. What is computational thought? Let's break it down. So first we need to understand what computation is. All right, so what is computation? So if we go and we look this up, it is the act or process, notice I underlined that, of computing or calculating something. All right. It's a system of reckoning. All right, so therefore, computation is an act or process. And we are going out and we are computing. And computing means what? What is computing? Well, let's get a definition for that. It's to find out something by using mathematical processes. And you're going to go, all right, why mathematical processes, right? I'm sure you're sitting there right now and you're thinking, all right, why mathematical processes? If we back up and we go back to CS 100, how does your computer work? Think about the circuits, not the software. A computer is comprised of circuitry and software. All right, so let's back up and let's talk about the computer itself. We solve problems through mathematical processes. It has adder functions in it, right? It has the half adder, the full adder. It knows how to put different combinations of ones and zeros together. So why mathematical processes? It's methodical. It's logical. It's step-by-step expression, right? Think about that. If you have a mathematical formula, it's a step-by-step expression, and you can walk through that methodical, that logical problem set to be able to develop a proof. Go back to your geometry days. You can develop a proof that proves and drives to a solution. In math, it's not just a process of saying x equals a plus b, and then you just arrive at an answer. So 5 plus 7 has a value to it, right? But there's a process that you walk through. There's a step-by-step set of instructions that prove that, yeah, that formula, that expression can be solved, and it drives to the solution. All right, so let's put it all together. What is computational thinking? It's the process of thinking about how to solve problems such that the solutions are, and you've seen these before, ready? Explicit, step-by-step, repeatable, and absolute. There, we just tied everything together. That's what computational thinking is. And I walked you through that process, didn't I? Just in the last topic. Because we took something so simple and arbitrary in our natural world of adding numbers together, and we broke it up into all of those steps to be able to say, hey, here's our process. We thought through the process. We came up with a solution that we expressed such that it was explicit. It was step by step. It was repeatable. It didn't matter if we were adding 10 plus 2 or 1,000,000 plus 8. It was repeatable. And it was absolute. It was always going to give you an expected behavior, an expected result. That is what computational thinking is. So stay right here. Focus on the screen. Break this down. Make sure you know what that is. It's crucial to your process of elevating and empowering yourself as a software professional. Developing computational thinking takes work. It takes time to develop that process to think in these types of steps, to be able to come up with the methodologies, be able to look at a problem set and be able to break it down. Because remember, computers do not think. You do. And you do that through computational thought. If a computer does what? So if we get rid of the R, what is it? It's computes. A computer computes. That's it. So therefore, it makes sense that we call what we do computational thought, because we're figuring out how to get the computer to do what we need it to do. That's it. So in computational thought, step 1, you identify the problem to be solved. Okay, that makes sense. Can't solve it if we don't know what it is. Step 2, you think about how to solve the problem. Then you're going to break down the solution into incremental, that's that step by step, actionable, absolute, and repeatable steps. All right? It's another way of expressing what I was just talking about. And you capture the solution in an expression. You express, notice I keep emphasizing express. Just like in CS 100, I kept emphasizing that data is a representation. Here we are expressing the solution in a way that anyone or any device could get the right answer. Why is that important? Why do I keep harping on that? Why is it so important that anyone or anything, any device, so if, whether it's my phone, an iPad, my computer, your neighbor's computer, a web server, whatever device is running your expression, why is it so important that it always gets the right answer? Well, what kind of device would it be if, for example, on your calculator, my calculator, when I put 10 plus 2, gives me 40, but yours gives you 12. And then you run it again. Oh, now the answer is 13. And now the answer is 102. It's not very useful, is it? So therefore, we have to come up with ways of capturing solutions such that anyone or any device can come up with the same right answer. So what does computational thought become? All right, so we've walked through these steps and we've expressed things, we've broken them down, and we capture those expressions, and they're repeatable and they're actionable, and they always give us the exact answer. All right, so what does that become? It becomes software. There's a purpose for this. Not just leading you on this journey of thought processes just because. No, it's leading you to what you do. You write software. So software is an expression of the set of instructions, right? That's our step-by-step instructions, which tells the computer explicitly how to do something. The computer's not smart, doesn't think, it can't reason. It's not intuitive. It can't sit and say, well, I think you meant this. Oh, you forgot a step, so I'll just put that in for you. Oh, you typed it this way, but I think you meant it that way. No, it can't do that. And that's why so many people get frustrated when they're trying to write code, because they're not understanding that what you write is all that the computer is going to do. It doesn't know how to figure out what you're trying to express to it. You have to tell it explicitly, this is what I want you to do, Mr. Computer. X, Y, and Z. Do it just like this. Make it repeatable every time. Just do this. I just want to make this very clear to you that building software is a thinking profession. You will hear me a lot through all of your training here with us. You will always hear me saying, thought experiments. Think about this. Do you see a pattern? Think, think, think. There's a reason for it. I'm trying to develop your computational thought processes. So what are the takeaways? Yep, let's just say it. Computers are stupid. Software tells the computer explicitly how to solve a problem. Computational thought is the act of expressing how to solve a problem. And building software is a thinking profession.